The following is an introduction to the UHV Power newly developed ZGF Intelligent DC Hipot Tester. It mainly has the function of automatic voltage boosting, and the function of automatically calculating voltage and leakage current for metal oxide arresters. Compared with the traditional DC Hipot tester, the biggest change of the intelligent model is in the control box. It changes the control box based on the traditional DC high-voltage generator. It allows it to use programs to automatically manage its automatic voltage boost, automatic current detection, and automatic data reading functions. Its wiring method is roughly the same as the traditional model, our intermediate frequency output and grounding. The learning cost of users in using the intelligent DC Hipot tester will be relatively small. Moreover, customers can also purchase an intelligent control box later to cooperate with the traditional one's multiplier, which can also realize some intelligent functions. Therefore, the learning cost and the configuration of the later upgrade have been taken into consideration. Then let's briefly introduce the panel of intelligent DC Hipot tester. It is similar to ordinary DC Hipot tester. Both have an intermediate frequency output, grounding, power socket and power switch. Here, the emergency stop and power switch of the original ordinary DC high-voltage generator are combined into one, facilitating the possibility of operation under extreme conditions, making emergency protection more convenient and quick. The following is a demonstration of the operation of intelligent DC Hipot tester to test the lightning arrestor. Connect this intermediate frequency output to the input of the voltage doubler using a professional intermediate frequency output line. Ground the ground terminal. The top of the voltage doubler is connected to a microammeter. In fact, when intelligent DC Hipot tester measures the lightning arrestor, you cannot connect this microammeter. For the sake of insurance, you can connect this microammeter. Then you can make a comparison with the data. In fact, it is also okay not to connect the microammeter, because its data is actually collected from the control box, not from this microammeter. If this thing is damaged on site, and there is no microammeter, you can still complete the lightning arrestor test. Then the test using the microammeter. Connected to the lightning arrestor. The lower end of the lightning arrestor is grounded. The wiring needs to be in accordance with the wiring of the ordinary one. It has been completed. First turn the power switch knob. There are manual tests, automatic tests, lightning arrestor tests, and stage tests. Record products and time settings. Record products as some test data can be saved. Then you can read it when you require. The time can be set. The time display in here. First, take a quick look at its function. This manual experiment can change the overvoltage and overcurrent protection. After changing it, click Start. On this interface, still need to manually press high voltage boost or high voltage drop to boost and reduce the voltage. It's boost and reduce. There are fast, medium and slow amplitudes. You can choose its amplitude. Won't explain this part in detail. This is not much different from the traditional manual mode. It just changes the previous knobs into some buttons. The main thing is to look at the function of this automatic test. The automatic test is to set the test voltage, its protection voltage and protection current, and set the withstand time. This is similar to the ordinary automatic control box. The boost speed can also be selected. Click to start. The instrument will automatically boost and reduce the voltage. Then manually discharge and remove the wires. The whole process is the same as the operation of an ordinary DC high-voltage generator. It's just that boost and reduce voltage are automatically completed by the instrument. The key point is to introduce this test of the lightning arrestor. I will operate it later. Now let's talk about the stage time, because there are some special tests products have requirements. It needs to rise to a certain percentage, and then stay for a certain period of time. This place gives a staged voltage to set. So for some test, voltage needs to rise to a certain percentage and stays. This stage gives a good automatic operation function. The settings of this place are similar to the settings of the automatic test. The target voltage and time, including protection voltage and protection current. So here connect to 6 kV line protection oxidizer line. Protector. Take this line protector as an example, to test the arrestor. The arrestor test is to do the breakdown voltage and leakage current. So the protection voltage needs to be changed. This protection voltage can set to 200 kV for the voltage multiplier. Take 200 kV as an example. Based on take 120 kV as an example. Just keep it consistent with the specifications of the product you bought. The protection current is also based on the product's protection. If it is a ratio of 2, use 2 mA. If it is a ratio of 5, use 5 mA. Keep it consistent. Here is 200 to 2. Set it to 200. Change it to 2 mA. Choose the boost speed to fast, which can be adjusted. People who do experiments on site like higher efficiency. Then the speed is faster. Click Start. You can see that the instrument will prompt. It is now boosting. This voltage is increasing. The current is automatically collected. When it reaches 1 mA, it will give this data. Then reduce the voltage. Reducing the voltage is to measure the leakage current. This interface pops up now. It is an interface of the test results. The voltage U1 mA here is the breakdown voltage value 19.1. U0.75 times the voltage is 14.5 kV. Of course, this is not to be looked at. Just to convert it. Then the leakage current is 0.002 mA. That is 2 microamperes. On this interface, the main thing is to read the breakdown voltage value and leakage current value. Then store, save to test data. For search later. You can also print. It mainly adds these functions. After the experiment is completed, click Return after storage and printing. At this time, use the discharge rod to discharge. After the discharge is completed, turn off. Its power supply is the same as its emergency stop. Just rotate it. Press it down.